All right, so now we're going to talk about a function that comes up quite a bit in algebra, and that is a linear function. Now, as the name implies, since it has line in front of it, or as part of it, a linear function is a straight line. It's not a parabola. It's not something like that. It's a straight line. You know, something along these lines, huh? No pun intended. Um, and basically, most of the time you'll see a linear function in the form of y equals mx plus b. And this is called the slope intercept form of a linear function. And what this shows is that your dependent variable depends on your independent variable, your value m, and m is the slope, and b is your y-intercept. And your y-intercept is the value where the line crosses the y-axis, if you were to graph this out. Now your slope that can be steep, it can be narrow, it can even be negative. But we express slope of a line in terms of the change in the y direction, in the y-axis, as compared to the change in the x direction, in the x-axis. It's a ratio of how fast you change in the vertical direction versus how fast you change in the horizontal direction. And so that's how we find our slope. It's the change in y divided by the change in x. Now sometimes you'll also see a linear function written in what's called point slope form, and that is simply y minus y1, where y1 is a known point. That's equal to m times x minus x1, where x1 is the x-coordinate of a known point that the line goes through, and this is called point slope. So we'll do a couple examples here that will show both of these forms of a linear function. So this first question we're being asked, first problem, we're asked to write an equation for the line in point slope form. And it says our slope is equal to negative 6 over 7. And it passes through the point 2, negative 5. Well, in this case, since they want it in point slope form, all we have to do is go back to our point slope equation, which is y minus y1 equals m times x minus x1. And in this case, if we're given all the information, we just got to put it in the right order here. So y minus y1 is the y-coordinate of a point that the line passes through. And we have that here as negative 5. So y minus a negative 5 equals m is our slope, and we're given that as negative 6 over 7, times x minus x1. x1 is the x-coordinate of a point that the line passes through, and we're given that as 2. So then we can evaluate it here. Y minus a negative 5 gives us a y plus 5 equals negative 6 over 7 x minus 2. And we could just leave it like that. That's point slope form. Y plus 5 equals negative 6 over 7 times x minus 2. And that's our answer. Now our next problem that we're being given is use the given conditions to write an equation in slope-intercept form. And what we're given is the line passes through there are 2 points, 1 and negative 3, and the point 4 and 7. So there's a few steps that go into this in order to write the equation. All right, so to find the equation of this line, we first have to, what we don't know is we don't know anything in order to do it. We don't know the slope, and we don't know the intercept, which are 2 things that we're going to need if we want to write it in the slope-intercept form. So, the slope is the change in y, and we're going to write that as delta y, divided by the change in x. And we get that by saying y2 minus y1 divided by x2 minus x1. And we have 2 points here, and we can designate either one as point 1 and point 2. We'll get the same answer for slope if we do it correctly. But we have to be consistent, and we can't say, all right, this is x1 and then this is y2. And if we say this one's point 1 and this one's point 2, we're going to stick with that. So that's just to make sure everybody's on the same page here. We'll say this is point 1 and this is point 2. All right, so now we can go back to our equation and say, okay, y2 is 7, y1 is negative 3, x2 is 4, x1 is 1. Yep. All right. 7 minus a negative 3 gives us a positive 10. 4 minus 1 is 3, and that's our slope. 10 divided by 3 is our slope. All right, so now we've got the first part of what we need for a slope-intercept equation. Now, to find the second part, and I'll change colors here, so the purple is our slope. Now we can come in and write the slope-intercept form. Y equals mx plus b. And since we've got 2 points here that this line goes through, we can use either one of these points and the slope that we just calculated and plug them into this equation to find out what our intercept is. So for no particular reason, I'll pick point 1 here to evaluate. So I'll say negative 3, because that's our y, equals 10 thirds, that's our slope, times x, which is 1, plus b. So, 10 thirds times 1 is 10 thirds. So that's easy enough. Negative 3 equals 10 thirds plus b. If I subtract 10 thirds from both sides of this equation, then I'll get negative 3 minus 10 thirds equals b. Negative 3 is the same as negative 9 over 3 minus 10 over 3 equals b. So b, ran out of room here. So b is negative 19 over 3 equals b. So now we have our slope, 10 over 3. We have our intercept, negative 19 over 3. So we can come back to our slope-intercept equation and say, write it out again. We can say y equals mx plus b. And then we can just substitute for the values that we found. Y equals 10 thirds x minus 19 thirds b. I'm sorry, that's not minus 19 thirds b, minus 19 thirds, because b equals 19 thirds. My mistake. So we get y equals mx minus 19 thirds. So y equals 10 thirds x minus 19 thirds. That's our equation in slope-intercept form. So again, if you're given a point in, we'll just review here. If you're given a point and slope and asked to find, and asked to write it out in point slope form, well, that's easy. You just plug it in. If you're asked to find it, if you're given 2 points and said write it in slope-intercept form, then you have 10 thirds x. So then you find the slope, you find the intercept, and then you plug those into your slope-intercept equation to write your line in slope-intercept form.